Good morning, everybody. Welcome to our webinar. This is the first of a series of a webinar introducing our latest, greatest release. We announced the release of our first release in 26 months. Today, our product manager, Cindy, will give us an overview of what's new in this release. And because we have too many things to talk about in this short time, so we will not have time to cover the details of every aspect. If some of you are interested in specific topics, to know more detail of some of the features, modules, packages in our products, please let us know. We can either plan for a more detailed webinar or a specific demo to your team. Okay, without further ado, Cindy, go ahead.
Hi, good morning, everyone, and thank you for joining us today. My name is Cindy Luo, and together with Ren Jun, we'll be walking through the latest capabilities introduced in subsurfaceAI 2026.1. And this release introduces a number of important enhancements across quantitative interpretation, visualization, data integration, and AI infrastructure. And throughout the webinar, we'll demonstrate the new capabilities through a series of demos and discuss how they can be applied in your workflows. Before we begin, I'll provide a brief overview of the release highlights. So the headline feature in this release is Rock Physics AI, a new package that brings rock physics modeling directly into the interpretation workflow. In addition, we introduced multi-Z interpretation for geobody boundaries, new visualization capabilities, including multi-volume visualization and base map annotation, expanded data integration with Petrol and Saswell, support for wavelet and well-list imports, and centralized core AI processing with enhanced system security. I'll now hand it over to Ren Jun to walk through the new Rock Physics AI package and its workflows.
Okay, so the Rock Physics AI is a new AI member of our product pipeline. So we introduced this. This is our first endeavor to introduce this Rock Physics AI workflow in this subsurface AI package. So what we have in the first release of this new package is that we have included 3 workflows of rock physics. First, we provide a functionality to help users build rock physics models and the rock physics templates. With our function, you are able to reuse any of the model and the templates that are calibrated with specific data set. And in addition, we ship with our own public rock physics models and the templates. The second workflow is utilize your calibrated rock physics templates and models for quantitative interpretation. So rock physics as a bridge between seismic attributes and the reservoir properties. The third workflow is the reverse of the second workflow. So you have, for example, you have a static or even dynamic reservoir model from Eclipse or CMG simulation, and you have saturation, pressure as a function of production time, and then you want to calibrate, you validate your static or dynamic data with your seismic data, either static or 4D seismic data. So you can generate synthetic seismic data from your static or dynamic models and compare with your real seismic data. So we have a workflow to allow you to generate synthetic 3D and 4D data based on the rock physics model and your reservoir properties. So in the next few slides, I will show you each step and what we included in the rock physics model. So we have 6 rock face models in this release, and we shipped our software together with the new 8 templates of different geology and the templates. For example, on your right side, we show you the default. When you install the software, you will see this immediately. There's nothing fixed. You can customize each of these models based on your geology, based on your reservoir and specific well data. That's the calibration process. So, what kind of a rock system model we include? So we have included 6 models in this release, and from classic, the rock system model is basically composed of 3 components. Dry frame model, we have quite a lot of selection. Fluid model, you have also quite a few sub models select. Most importantly, you need to select fluid substitution models. So we have 6 of them. Classical Gassman equation, generalized Gassman equation that is suitable for SAGD project, for example, in Western Canada or the oil sands. You can use Gassman equation because that assumption is broken down. So you have to use revise the Gassman equation. Then we have 2 empirical relationship, and for monthly or shale or these more heterogeneous reservoir, you have 3 subtypes of Brown Cornium substitution model. So each of these models, they work under a certain assumption. So your reservoir, your objective has to be consistent with the assumption of the specific reservoir model, rock face model you choose. And I will not go too much detail about this. And next, I will show you the workflow 1. How do you customize your rock face model and templates with your specific data? So here you start with your default with our ship default model, and you can here is just a quick view. And after you build your own model with your own parameters, you can name the model whatever you like. And rock face template is nothing more than an overlay of a reservoir property on the rock face model. So you can see you have quite a lot of selection of a dry frame model, and can add different components depending on the model you have. Say, kind of looking for unconventional fracture, isotropic or anisotropic fracture type of models as well. And so this rock system model used to be a specialist tool. Now we are include this as a easily accessible, easy to use as part of the general seismic interpretation workflows. And you can still utilize the expertise of a specialist and to build this template and store them as the specific templates to be reused, shared among the team. And then you can export even in JSON file format. So how do we collect? How do we calibrate them? So if we just go to the next slides. So this second workflow, well, now just quickly get to the second workflow, which is the computative interpretation of seismic inversion results. VPVS density that are normally 3 elastic property you get from precedent inversion, and they are not necessarily one-to-one relationship with the reservoir property you are interested in, say saturation or your gas chamber movement. They are linked with VPVS density, but the relationship has to be linked through specific rock face templates, which you built this before. So to assume you have this template built already, you want to convert your elastic property seismic inversion results to reservoir properties. So here, you just like in our software, you just like compute a lot of attributes. You start reservoir value, to calculate the reservoir property from rock physics model. You select the rock physics model. This can be different for each different fishes or different rooms. And you select the VPVS. Density could be a constant, could be based on Gardner equation, or could be inverted density volume if you're lucky have a non-wolf side, a data set. And then output is the reservoir property, porosity, saturation, and how do we invert this? We could based on different rock method. So here is a synthetic example from a Norwegian field called a wolf data set. So you can start this, and then the reservoir property, and then the data interface is very similar to any of our seismic attributes calculation. So you can select your template tabs. So here I have density volumes, and you can define your saturation or select a rock physics model. So here I will use SEG as an example, SEG model as an example. Stop sign. And by default, we don't export saturation volume. So you could select them, and then you're allowed to set your perspective load. Hit OK, and then you will generate 3 volumes: saturation volume, porosity volume, and base shell volume. And we have the functionality to resample this seismic attribute inversion result derived saturation porosity data to a reservoir grade. So you can import a reservoir grade in the industrial standard format. Here now I can resample this data to a static reservoir model. So here is a different ways, seismic driven approach to derive the property for your static reservoir models instead of just a random number from just statistics. Okay, so this is the second workflow where seismic data, assuming you have a reasonable quality, can contribute a lot to the static reservoir management and reservoir modeling. So now it's the third workflow. Third workflow is just an inverse. So you go to, so you will have static reservoir model build or dynamic model from the simulation. You want to validate this porosity, saturation, grade, and because you want to have your model a forecasting capability, you need to validate your observation from 3D seismic data. Or if you have even better, from 4D seismic observation, you see the changes of velocity, of density, but they are not singly related to a reservoir property. So you have to use the rock physics model as a bridge to link with your the changes of your velocity to the changes of your saturation. And the bridge is the rock physics model. Here I have 29 years of wall field simulation based on simulation Eclipse simulation case data. So you can easily import that, and you can generate VPVS density for each of this kind. And we provide a synthetic modeling function where you can select the wavelet, either it's extracted or analytically defined, or wavelet volume that you need to extract from your real data. And here, so now you can after you compute the VPVS density, then you can generate a seismic volume. Seismic volume are different format than a strata grade, than a reservoir grade. So you can define your seismic synthetic seismic volume geometry. Then afterwards, you would the end results is seismic volume. Here allow you to select wavelet, and then the end result is synthetic volumes for each type's data. So this is how you generate synthetic seismic volumes. So these are the, so maybe you can, before we close, so you can show this is the synthetic seismic volume we generated for a given time. This is the 4D seismic volume. we do have a capability of interpreting or even calibrating 40 centimeter data with from base volume. So that's beyond the scope of this webinar, and we can talk about this afterwards as well. So this is just show you the synthetic sediment volume we generated from dynamic simulation results. Okay, so I just conclude our Rockfish AI's function overview. So we provide 3 workflow of a Rockfish related workflow. Calibrate a Rockfish model with your own data and do a seismic quantitative interpretation of prospective regression results. And then thirdly, generate synthetic seismic data, synthetic volumes from your static or dynamic simulation results. Okay, so now I transfer to Cindy, continue the work. Yeah.
Great. Thanks, Renjun. So next, I'll walk through the remaining enhancements introduced in Subsurface AI 2026.1, beginning with the multi-Z interpretation for geobody boundaries. So multi-Z interpretation provides a more flexible approach to defining complex geobody boundaries. Users can define multi-Z values within a single interpretation and convert those interpretations directly into geobody labels for downstream workflows. Let's take a look at a short demo. So here I'm displaying geobody probability volume, and I'm enabling the multi-Z interpretation tools. And I'm creating a new multi-Z interpretation and start digitizing the multi-Z interpretation along the geobody boundaries. So in this process, you can redo and undo at any time and double click at the end. So this is a one multi-Z interpretation on this section. And after digitizing it, you can further edit it. Then we can go to another section, which you can see there is already a projection on the section for this multi-Z interpretation. And based on that, we can digitize another multi-Z interpretation along the geobody boundaries. And between these two sections, we can see the projection of this multi-Z interpretation. For the multi-Z interpretation, we can further convert it into a geobody AI label, and then display that on section, and as active AI label, you can see these two sections, which have the geobody label, and we can further edit this geobody label before we train the AI model. And then we can start training our geobody AI model. So as shown in this demonstration, multi-Z interpretation allows interpreters to define more complex geobody geometries while maintaining a simple and efficient workflow, and the resulting interpretation can be converted directly into geobody label for further analysis and AI workflows. Another enhancement in this release is the ability to overlay and visualize multiple volumes simultaneously. This allows users to overlay multiple volumes in a single view and compare seismic and attribute data more effectively. And the workflow supports datasets with different dimensions and resolutions, and we can also use RGB and co-rendered volumes as the inputs. And this capability is available for volumes, intervals, stratigrades, and horizons. Let's see how this works. So I'm starting from data volume and right-click, select define overlay object, and we can select multiple attributes to overlay them together. And in this case, I'm selecting some spectral decomposition volumes and also the curvature volume. Here, for each attribute, you can adjust its display range and also the transparency curve. So the first attribute we select will be opaque, and the other attribute will be transparent. Then an overlay object has been created, and we can visualize them in our visualization windows. Here, we can still reach to this overlay project objects properties page, and then adjust its visualization settings at any time, and it will update on the sections immediately. So it's very flexible. And you can also reorder this attribute and to change its overlay effect on the sections. Also, you can add any more attribute to this overlay object. And apply it to see the changes. And also you can remove any attribute and apply the changes. So overall, this is very flexible functions for the visualization. And in the base map window, we can also display this overlay object and slicing through the time slice. So you can see the effects for that. So the multi-volume visualization provides a more effective way to compare multiple data sets and identify features that may not be apparent when viewing individual volumes separately. And here you can see this is multi-volume visualization, which is very useful for the visualizing the AI predicted results. We've also introduced the base map annotation capabilities. Users can now add notes and comments directly on the base map, making it easier to capture interpretation insights, document observations, and improve collaboration across project teams. So let's look at a quick example here. So in our base map window, we can enable our annotation tool and add new notes at any location on the base map. And here we can enter the note. And in default, there is an arrow attached to the note. Then it shows the notes on the data tree as well as on the base map window. And you can reach to its properties page to change the settings. So firstly, the anchor point with the arrow on the anchor point of this node is the arrow tip. So you can either drag that on the base map, or you can change the anchor point coordinates in this properties page. And also you can change the visualization settings for each component of the node. For example, the color, font, and size, style of the boundary, the arrow. For example, I'm changing the color for the text box and the boundary for the arrow, and also the color for the text, and then apply it to reflect on the base map. And you can drag the node as well on the base map to change its direction. And you can also change the degree in this properties page. So it's very flexible. And you can also change the length, the width, the head height for the arrow. And in this text box, you can adjust the text and apply the changes. So these are the settings you can control for the node. And you can also disable that arrow, so it becomes a pure text box. And you can further drag that on the base map. And here I'm adding another node here on another location. So that becomes a node 2 on the data tree, and you can define its individual settings. So this capability provides a simple way to preserve interpretation context and the project knowledge directly within the workspace. Subsurface AI 2026.1 expands our Petrol integration by supporting additional object types, including the multi-Z interpretation and geobody objects. So this enhancement further improves interoperability between subsurface AI and Petrol and streamlines data exchange between platforms. Let's take a look. So here we have a Petrol project, which we have two multi-Z interpretations on this section. And we also have geobody interpretations displayed in a 3D window. Now I want to import those objects into subsurface AI project. And this is the subsurface AI project, which I already imported the data volume. Now I'm starting the data exchange with Petrol project. And here I'm selecting the geobody object and also the multi-Z interpretations. Then we start the importing process. So it will take some time depending on how large your object is. And now they have been imported, so we can check them on our section. So these are the multi-Z interpretations. And they have been imported correctly. We can also check the geobody object. Display that in the 3D window. So you can see this is a large geobody object we have imported from the Petrol project. So this is about import these objects from Petrol to subsurface AI. Now I also want to export. So here I interpreted some geobody objects inside subsurface AI project. And also some multi-Z interpretation. Now I want to export those objects to Petrol project. So again, we go to the data connector. And this time we select subsurface AI to Petrol. Then we select the geobody object as well as the multi-Z interpretation. Then we start the exporting process. So you can see very quick, and they have been successfully exported to Petrol. And we can check those objects in Petrol. So I'm displaying the same section and here, and you can see this is the multi-Z station exported to Petrol project. We can also check that geobody object in the 3D window here. So you can see this is the geobody object we exported from subsurface AI to Petrol project. So users can now transfer a broader range of interpretation objects between Petrol and subsurface AI, which helps maintain consistency across integrated workflows. We've also significantly improved the performance and stability for our access well connectivity. While the workflow itself remains familiar, users should notice a much faster and more responsive experience when working with access well connected projects. So here I'm showing you an example about how quick it is to import large access well project. So I'm selecting a large access well project. which contains multiple 3D data volumes. And in this project, we have 659 wells. We have a bunch of horizons and also some capture data. It was okay to import, and you can see how quick it is. It's importing the seismic first, and then it's importing the wells. So within 10 seconds, everything has been imported. And we can check them on the data tree. And these are the seismic volumes for different surveys. And here we have all the wells and horizons, and also the capture data. And you can further check them in the visualization windows inside subsurfaceAI. So these enhancements improve the overall user experience and make working with SaaS-well connected projects more efficient and reliable. A new wavelet import workflow has been added in subsurfaceAI 2026.1. The workflow supports both ASCII and SegWi wavelet formats and allows imported wavelets to be used throughout interpretation and modeling workflows. Here is a quick example that we go to import wavelet. And you can see we support both the ASCII and the SegWi format. And firstly, I'll select the ASCII format and select wavelet text file and open it. So for the ASCII file, we need to define the data start range and then delimiters, also the column for time depth and amplitude, and define phase. And then the wavelet has been imported. Then we can check it in our wavelet window. So this is the imported wavelet in ASCII format. And another format we support is a SegWi format. So this time I'm selecting SegWi format, and I'm selecting a wavelet exported from SaaSwell. And then we define the sample format and also some other parameters. And this is a preview for the wavelet. Then after importing, we can also check it in our wavelet window. So this enhancement simplifies the process of bringing external generated wavelets into subsurfaceAI and improves interoperability with other software platforms. We've also added support for importing well list directly from text files. The input file is a simple text file containing one well identifier per line. Each entry can be either a well name or UWI. So you can see we start from import well data well list and select the text file. And this is the file example here. Before importing a well list, the corresponding wells must already exist in the project. If a well in the file cannot be matched, it will be ignored and a message will be displayed identifying the unmatched wells. And once imported, the well list can be used throughout visualization, interpretation, and analysis workflows. This provides a simple and efficient way to organize groups of wells and reuse those selections across multiple workflows. The final enhancement I'd like to highlight is the modernization of the underlying subsurfaceAI architecture. With subsurfaceAI 2026.1, AI processing has been migrated from the client workstation to a centralized GPU server. And this provides improved scalability and performance while reducing client-side requirements. And by centralizing core AI processing to the GPU server, deployment and maintenance are also simplified, making it easier to manage AI resources across an organization. In addition to this architecture improvements, we've strengthened platform security. User management can now be integrated with Active Directory or Microsoft Entra ID, providing a more streamlined authentication experience for enterprise environments. We've also implemented SSL-enabled communication and secure data exchange among the subsurfaceAI client, GPU server, Redis, and PostgreSQL components. Together, these enhancements provide a more scalable, secure, and enterprise-ready foundation for future AI-driven workflows. So the key takeaways for this webinar is, firstly, the rock physics AI package enables quantitative interpretation and synthetic seismic workflows. And the multi-Z interpretation simplifies complex geobody boundary definition and label generation. New visualization capabilities improve data analysis and collaboration. And the expanded data integration streamlines interoperability with industry platforms. And our centralized core AI architecture enhances scalability, deployment, and security. All these enhancements continue to expand subsurfaceAI as an integrated platform for interpretation, quantitative analysis, visualization, and AI-driven workflows. We look forward to seeing how these new capabilities can support your projects and workflows. And that concludes our overview of the new capabilities introduced in subsurfaceAI 2026.1. Thank you for joining us today, and we'll be happy to answer any questions you may have.
Thank you, Cindy.